Cavity wall. Cavity wall is constructed with two separate walls for single wall purpose with some space or cavity between them. These two separate walls are called as leaves of cavity wall. The inner wall is called as internal leaf and outer wall is called as external leaf. Cavity wall is also called as hollow wall. For non-load-bearing cavity wall, two leaves are of equal thickness or sometimes internal leaf with more thickness is provided. The cavity size should be in between 4 to 10 centimeters. The internal and external leaves should have at least 10 millimeters thickness. The two leaves are interconnected by metal ties or links. Construction of cavity walls. In general, cavity wall doesn't require any footings under it, just a strong concrete base is provided on which cavity wall is constructed centrally. Two leaves are constructed like normal masonry, but minimum cavity must be provided in between them. The cavity may be filled with lean concrete with some slope at top up to few centimeters above ground level as shown below. Weep holes are provided for outer leaf at bottom with an interval of 1 meter. Normal bricks are used for inner leaf and facing bricks are used for outer leaf. Different masonry is also used for cavity wall leaves. T. Leaves are connected by metal ties or wall ties, which are generally made of steel and are rust-proof. The maximum horizontal spacing of wall ties is 900 mm and maximum vertical spacing is 450 mm. The wall ties are provided in such a way that they do not carry any moisture from outer leaf to inner leaf. Advantages of cavity walls. Following are the advantages of cavity wall when compared to solid walls. Cavity walls give better thermal insulation than solid walls. It is because of the space provided between two leaves of cavity walls is full of air and reduces heat transmission into the building from outside. Economically they are cheaper than solid walls. Moisture content in outer atmosphere does not allowed to enter because of hollow space between leaves. So, they also prevent dampness. They also act as good sound insulators. They also reduce the weights on foundation because of their lesser thickness. Outer efflorescence is also prevented. Disadvantages of cavity walls. Highly skilled labor and masons are required for cavity wall construction. Require standard supervision during its construction. A vertical damp-proof course is also necessary for it. Floating floor. Acoustic floating floors control the transmission of sounds and vibration from floor impacts to the surrounding building structure. The floating floor is often paired with acoustically isolated walls and ceilings, creating what is known as a box-in-box construction. This setup helps to control sound and vibration in a safe, controlled way across a single space. Acoustic floating floors can be installed on any floor so long as the underlying subfloor is structurally sound. No structural work is needed on subfloors so long as they are level. If leveling is required, this can be done relatively easily. An acoustic floating floor is a suspended floor structure that sits above a solid subfloor, creating an air gap. The air gap isolates sound and vibration to the floating floor, improving the acoustic qualities of the flooring system. We specify acoustic floating floors for a variety of reasons. The most common reason is to isolate sound and vibration in a room. The beauty of acoustic floating floors is they are highly modular and configurable, so we can fine-tune the acoustic qualities for different applications. A typical acoustic floor has the following layers. Subfloor. Formwork. Concrete pour or particle board. Acoustic mastic. Rubber/foam underlay. Top surface, for example, rubber tiles. The sound and vibration damping effect of acoustic floors is achieved with rubber isolators that extend through the structure, helping to isolate impacts to specific zones on the floating floor. The system itself is comprised of several layers, including metal formwork and concrete wet pour or concrete board. We can cover acoustic floors in anything from carpet to boards. The most important thing is that the top surface is specified for the intended application. For example, carpet isn't considered suitable for dancing, but it is for yoga. Floating floor construction detail. Floating floor construction detail. Wood joist flooring. Soundproofing timber floors requires limiting impact noise transfer with a cushioning layer to absorb impact vibration. Proven acoustic insulation solutions like sound mats act like a floating floor, which help to absorb impact vibration before it enters the structure of the floor. Add mineral wool between joists to reduce sound amplification and increase floor mass to block unwanted airborne noise by using different types of mass to block different frequencies. Wood joist floor construction detail. Plenum barriers. This plenum barrier blocks the sound that transmits through the suspended acoustic ceilings, increasing the overall performance. The most effective method of reducing sound transmission through the ceiling is to introduce a barrier into the plenum. The plenum barrier can be limited in length, it only has to be positioned above the wall between the two adjacent rooms. The plenum barrier does not need to extend around the entire perimeters of the rooms. A limited plenum barrier allows return air to still flow freely through the plenum. Plenum barrier advantages: improved sound isolation and privacy between rooms, installs quickly above interior partitions, lightweight and easy to cut, conforms around pipes and ducts, expands and contracts with deflection. Plenum barrier construction details.